Exercise 9.3, question number 12th we did in the last session. Now we'll continue with the question number 13. Their geometric progression, you are given 3, 3 square, 3 cube and so on. What is the question? How many terms of this geometric progression to give the summation equals to 120. So find it for which Sn equals to 120. Right? That is the question. So what we need to do? Just we need to use the formula for Sn. A, you know here what is A? A, you know it is 3. A is 3. What is common ratio? Common ratio is also 3 here. Right? Okay. So now we just use the formula for Sn here. Let's write Sn equals to 120. What is the formula for this? A into, you know, r raised to n minus 1 upon r minus 1 equals to 120. A we know. What is A? 3. R also we know. What is R? 3. So 3 raised to n minus 1 upon 3 minus 1, which is 2, equals to 120. So therefore 3 raised to n minus 1 equals to 120 into 2 by 3. Fine. So what we'll get here? 3 raised to minus 1 equals to, here we know this will be just 40, so 80. And therefore 3 raised to n equals to 81. And 81, you know, it is nothing but the 3 raised to 4. So therefore n has to be 4. Fine. It is just based on, you know, simple formula. Not a big task here to do this question. Okay. Now next question. What about next question? The sum of the first 3 terms of a geometric progression is 16. Okay. So let me do here only. Question number 14 here. Sum of the first 3 terms. So A plus AR plus AR square. These are the first 3 terms, which is equals to 16. Call that as 1. The sum of the next 3 terms is 128. Next 3 terms means now we have AR cube, AR raised to 4, AR raised to 5. Equals to how much? 128. What is A here? First term. What is R? That's a common ratio, you know. Right? And you are asked for find A and R. That's a question. So what is A? What is R? This is what you want to do here. So what we do? We use just here equations 1 and 2. So you can see that by 1, what is common? You will find A common. So 1 plus R squared equals to 16. And by 2, what is common? You will find how much common? AR cube. So let's take AR cube common from second one. If I take AR cube common, this is 1 plus R squared, which is equals to 128. Right? Now take the ratio of these two. Normally when you have product, you should take the ratio, or you can place the value of this much over here. This much can be placed here. You can write like this, A into this much, you know, you can put that. Okay, so I'll write here, I'm putting the value of this into this. That is R cube as it is. What is this? 16 equals to 128. Is this clear to you what I did? Have you realized? I've used the previous equation. So I've just placed the value of each expression here. Value of each expression here, this much. A into this much. I've placed this much. A into this much, which is how much? 16. Okay, so R cube equals to 128 by 16. Fine. So from there you will get just 8. And therefore R has to be how much? It has to be 2. So R is 2. Once we get R, you put in this equation. Let me call this as 3. So immediately you will get the A. So by 3, let me write by 3, A into 1 plus 2 plus 4 equals to how much? 16. So A equals to 16. This is 7 by 7. So A is 16 by 7. Now what is asked further? Further something more you are asked. That is nothing but what? Sum of n terms of this geometric progression. So further you want this. Also you want this. What you want? Sn. N terms. A into r raised to n minus 1 upon r minus 1. Just place the value of r here, place the value of a here and simplify. Your answer will be in form of small n, remember, because you are asked for sum of how many terms? N terms. So just put the value of a and r and simplify as much you can do. That is nothing but here value of Sn. Question number 16, 15 you can try. It's a very simple question. For a geometric progression, you are given that sum of the first two terms is minus 4. So we are given this, given that S2 equals to minus 4. So write its formula. What's the formula? A into r raised to 2 minus 1 upon r minus 1 equals to minus 4. Call this as one equation. Okay. And one more thing you are given. What is that? The fifth term, that is A5, equals to 4 times third term, that is A3. So we just write the formulas for both. What is the formula for this? A into r raised to n minus 1. 4 as it is. A into r raised to n minus 2. So r squared. We know the formula. What is the formula for a into r raised to n minus 1? Here 5, so 4. Here 3, so 2. Now we have these two equations. One is this, the other one is this. From these two, you just need to get a and r. That much. That's the only important part here, right? So I'll simplify here. A will get cancelled. So you'll get the r squared equals to 4 here. And therefore, what is r? Therefore, r is plus or minus 2. Fine. Now, we put these two values where? Plus or minus 2. From the above equation, we'll get the a. So here you have two possibilities. In fact, if r is 2, you will get a. If r is minus 2, you will get a, remember. So by 1 here, a into r squared, that is 3, upon 2 minus 1, that is just 1, equals to how much? Minus 4. And therefore a equals to minus 4 by 3. So one possibility for a is this. Okay. If you take minus 2, go to the same equation, this one. A into, this is 3, r square. And what is this? This is minus 2 minus 1, which is minus 3 again. And equals to minus 4 is there. And therefore, 3 will get cancelled. You will get the a equals to 4. A is how much? 4. And therefore now GP is, so there are two possibilities, either this or this. So I'll write the geometric progression R. If I use this, what is the geometric progression? A, which is minus 4 by 3. Next term, A into R. A into R, that is nothing but what? This into this, which is minus 8 by 3. Then again AR squared, that is this into this, which is minus 16 by 3, and so on. Or now we'll start with this. What is A here? 4. A into R, R is here, minus 2. So minus 8. Again multiply with minus 2. So how much? 16. Again multiply with this, which is minus 32, and so on. So these are the two possible geometric progression. The question was find the GP. That was the question. So we got the two geometric progressions. Fine. Let's go to next question. What about next question? There, what is asked? 4th, 10th and 16th term of a geometric progression are x, y and z, then prove that these are in GP. Question number 17. X is A4. So x equals to A into R cube for a geometric progression. What is small y? That is 10th term, A10. So y equals to A into R raised to 9. And small z, what is small z? That is nothing but the A16, 16th term. So we'll get the here small z equals to A into R raised to 15. You can call this as 1, 2 and 3 if you want. Let's call this. What we did? We have just used the formula for an for a geometric progression. A into R raised to n minus 1. We have used this. How many times you have used? 3 times here. 4th term, 10th term and 16th term. Prove that x, y, z are in GP. That's a question. So what we do? We just get the ratio. Which ratio? Ratio of successive terms. We find y by x, sorry. Now we find this ratio. Right? You want that this are in GP, remember. You want this are in geometric progression. So these upon this and these upon this, that is z by y. These two ratios should be equal. Now write y by x. What is y by x? A into r raised to 9 upon a into r cube. So a will get cancelled. This is r raised to 6. What is z? A into r raised to 15 upon a into r raised to 9. So again this will get cancelled. This is r raised to 6. So therefore ratio is constant, equals to some constant, and therefore these three terms are in geometric progression. Fine, very easy. Whenever you want to show that three terms are in GP, you just need to show this. Next question. Let's go to question number 18 here, which is really nice question. So in the 18th question, you are given one sequence and you are asked for SN, right? So here question is to find the SN. That's a question. To find SN, sum of the n terms of a given sequence. So SN means sum of how many terms? You know, n terms. So 8 plus 88, 888 and so on for n terms. Now if you observe carefully, this is neither AP nor GP. This is not arithmetic progression or not geometric progression. So directly you cannot write any formula of GP or AP here. So we try to convert into one of them. So here standard method is, you can see there is 8 common. So 1 plus 11 plus 111 and so on. For how many terms? For n terms. Okay. Now next procedure in such questions will convert into 9. So I'll divide by 9. And internally I'll multiply with 9. So 9 plus 99 plus 999 and so on. Right? Why we did this? You will realize now. Because now you see inside the bracket I can rewrite like this. 8 by 9 as it is. This I can write 10 minus 1. This I can write 10 square minus 1. This I can write how much? 10 cube minus 1 and so on. Fine. Now you can see that this 10 square, 10 cube is a geometric progression. So 8 by 9 outside as it is. So 10 plus 10 square and so on. For how many terms? N terms. So 10 raised to n. This is GP. You must have noticed first term is 10 here and common ratio is also 10. This is a geometric progression. Minus, now here you can see, take minus common, then 1 plus 1 plus 1. How many times? N times. So this is small n. 1, 1, 1, if you write 3 times, it is 3. 1, 1, 1, if you write 4 times, it's a 4. But here it is what? N. Okay. Now we just need to use the formula for GP for first one. Now we'll use the formula for GP for first one. 8 by 9 as it is. A 10 r raised to n, that is 10 raised to n minus 1 upon 10 minus 1 minus 1 1 1. How many times? N times. That is small n. What is this geometric progression? Sum of how many terms? N terms. A is 10, common ratio is also 10. So you have used that A into R raised to n minus 1 upon R minus 1 formula. So now the last step here, the last step will be 8 by 9 as it is outside. What about this? 10 into here 10 raised to n minus 1 upon 9, 10 by 9 minus n. This is nothing but the required SN. Right? If you have any such question, you can refer illustration. If you have 2, 2, 2, something like this, for example, 2 plus 2 plus 2 like this, then again take 2 common, 2 outside, multiply and dividing by 9. Always will reduce into 9. Right? So keep in your mind that there is nothing special about 8 in this question. Okay. Next question, question number 19 here. In the 19th question, see what it says. Please read the 19th number. Yes, find the sum of products of the corresponding terms of the sequences these and this. Okay. So you are given two sequences. The one sequence is 2, 4, 8, 16 and 32. You know that is the geometric progression. Right? What is A2? Common ratio is also 2. You can see. This is a GP with R equals to 2. Common ratio equals to 2. First term is this. And what about the other progression? Second one. Let's write that. 128. Then this is 32. Then this is 8. This is 2. And here you have half. Is again. You must have noticed by writing geometric progression with R. What is R? Right? These upon this, these upon this, these upon this. If you write it, you will say that it is 1 by 4. Here common ratio is 2. Here common ratio is 1 by 4. So therefore, the required summation is this. Required summation equals to how many terms you have? You have just 5 terms. So required summation is this 2 into 128 plus 4 into 8, no 4 into 32, I'm sorry, 4 into 32 plus 8 into 8 plus 16 into 2 plus what we have? Plus we have 32 into half. Right? Is also a geometric progression, is a GP. Where first term is this with A equals to this into this, which is 256. What is R? You can verify. You do this upon this. That's usually product of these two. That is 2 into 1 by 4, which is just half for this. Right? This actually very fundamental concept. If these are the two progressions with their common ratio this, then the product has the product of these two as a common ratio. So here common ratio is half. You can just verify. Do this upon this. You will realize. You can see this is 32. This is 64. So it has to be half. How many terms you want to add? 1, 2, 3, 4, 5. So n equals to 5. Now use the formula A into R raised to n. R raised to 5 minus 1 upon R minus 1. Right? You know A. You know R. So you can just place the value and simplify. So you will get the required summation. You know A. What is A? 256 of this sequence. Remember, what is R? R is just how much? Half. Right? So just place the value and simplify. So this much I'm sure you can do it. Okay. Question number 21 now. 20th you can do, not a difficult question. Find 4 numbers forming a geometric progression. Okay, so let 4 terms of a GP, 4 terms be this A, AR, then AR square and AR cube. You know, these are the 4 terms of a geometric progression. To get this, you need A and R. That is indirectly question. What we need to find? Small a and small r. That is a question. So here you are given 2 conditions. Let's read those 2 conditions. What's the first condition? Third term, right? And you are given this, and third term is greater than first term by 9. So in the first term, if I add 9, both will be equal. Okay, that's the one condition. And what is the other condition? Next condition, the fourth term, the second term is greater than fourth term by 18. So second term A2 is greater than 18, the fourth term. So in the fourth term, if I add 18, I'll get the second term. Second term is greater than by 18, the fourth term. So you have this. Now just write the formulas. You must have two equations about A and R, and we solve them and we place here. What is A3? You know, it is AR squared, right? A1 means A here, plus 9. The one is this equation. What is A2? A2 means the second term, that is AR. What is A4? That is nothing but the AR cube plus 18. Okay? Fine. Now we just solve these two equations for A and R. So normally in geometric progression questions, we select the ratio. I'll take A over here, and then we just take the ratio. See, from 1 in the next line, you will find A common. So R square minus 1 equals to 9. And there I'm going to take AR common. So what you'll get? 1 minus R square equals to 18. From the above two equations, just observe carefully. Take the ratio, taking ratio. Or another way of saying, you are putting the value of AR square minus 1 over here. Or in geometric progression, you are just taking a ratio. If you take a ratio of above equations, what will get? Here minus sign will be there. I'm writing this upon this. So you'll get the here. A will get cancelled, you'll get the minus sign. So we have minus R, and you have 9 by 18, which is just half. So therefore R equals to minus 2. Therefore R equals to minus 2. Now put the value of R in any one of those two equations. So by 1, R is minus 2. So A into 4 equals to, you have A plus 9. So 3A equals to 9. So A equals to 3. Okay. So R is this, A is this. Now therefore terms are, where we are putting A, that is 3. Then AR squared, 3 into minus 2 whole square, then AR cube, just AR, then AR squared, that is 3 into minus 2 whole square, and then AR cube, that is 3 into minus 2 the whole cube, and therefore you have 3, then you have minus 6, then you have 12 here, and then you have minus 24. These are the required terms. Fine. It is just about elimination, nothing more than that. What you did, you have used just this relation, written the formula, we have solved this. Normally in AP questions we use the addition or subtraction. In GP questions we take the ratio. So I have just taken the ratio. You are getting R. Once you know R, you can get the small a, and then we have placed there. Okay. Sure. Now let us go to next question. What about next question? 22. We had earlier such question. So let me do that here, just at least beginning. Question number 22. We had a same question in AP. See what is here given to you. Small a, b, c are pth, qth and rth term of a geometric progression. Then prove this equals to 1. So for a geometric progression, for a GP, earlier we had a question in AP. Small a is equals to pth term. We write its formula. A equals to pth term means, now small a is already used, so I'll use big A here. Small r is also used somewhere, so I'll use big R here. RS2 P minus 1. For a GP, let first term equals to B capital A and the common ratio equals to, I'll write big R. Right? That we have assumed for a geometric progression. Why we have not used small r? Because small r is already used in the question. Why have not used small a here? Because small a is already used in the question. That's why. Chalo, what is small b in the data? Small b is which term? Qth term. So AQ. That is b equals to a into rs2 q minus 1. And what is small c? Small c, that is which term? Rth term. That is small c equals to a into r raised to r minus 1. Small a, pth term, qth term, and this is rth term. Now there is nothing, you just start with LHS of what you want to prove and you just place the value of a, b and c. Fine. So I'm just starting with LHS of what you want to prove. Left hand side. What is left hand side? That is a raised to q minus r into b raised to r minus p into c raised to p minus q. Okay, small a. What is small a? That is a into r raised to p minus 1 the whole raised to q minus r into what small b? That is a into r raised to q minus 1 the whole raised to r minus p. What I did? I have just placed the value of a, b and now c. What is c here? C is nothing but a into r raised to r minus 1. Fine. Now we are just simplifying and you will see that you have that power equals to 0. I'm collecting powers of a's. So a raised to q minus r into a raised to r minus p into a raised to, sorry, I forgot to write that power. That power is p minus q here. A raised to p minus q into now power of big R. This into this, which is p minus 1 into q minus r. Power of the power gets multiplied. R raised to q minus 1 into r minus p into here r raised to r minus 1 into p minus q. So now bases are same, so you can just add the exponent. This plus this plus this. Just adding these exponents into, I'll write here, r raised to this 3. P minus 1 into q minus r plus q minus 1 into r minus p into, sorry, plus r minus 1 into p minus q. Fine. Now, what about this? A raised to, you see this, PP will get cancelled, QQ will get cancelled, RR will get cancelled, A raised to 0. I leave it for you. You just open all the bracket. You see here your PQ, here your minus PQ. So you will notice that also 0. So you have 1 and which is RHS. Fine. So again, not a difficult question. Now let's go to next 23rd. 23rd, question number 23 here. The first and nth term of a geometric progression are small a and small b respectively. So here a1 is a and n equals to b. This is given. What is asked? If the p is the product of n terms, okay, so let n terms of GP, let the n terms be this a first term, then ar squared and so on, a r raised to n minus 1. You know this is the nth term which is actually b. So we are given this, their product a into ar into a, I'm sorry, here it should be AR and then AR squared here. So AR squared and so on a into r raised to n minus 1, that is equals to how much? You are given big P, that is equals to P. So let me simplify. A will occur how many times? N times. A into A, that is a raised to n. A raised to n. Here r raised to 1 plus 2 and so on up to n minus 1 equals to P. Now this you know probably, otherwise you will come to know later on in this chapter even. Some of the first n minus 1 numbers. If you just remember 1 plus 2 plus 3 up to n, some of the first n natural number, n into n plus 1 by 2. You might be knowing, otherwise we'll learn it in this chapter. Here this is a sum of how many terms? N minus 1 terms. So in this, just replace n by n minus 1. So n by n minus 1. So n minus 1 plus 1, that is n by 2 equals to P. Fine. We have this much. Now what you want to prove? You want to prove P squared. So I'll just square this. You want P squared. So squaring equals to here. This is a raised to, you know, power of the power gets multiplied. A raised to 2n. Here 2 will get cancelled. So r raised to n minus 1 into n. This is P squared. And what about here RHS? That is nothing but the a into b the whole raised to n. What is a? That's the first term. That is a. And what about b? That is nth term. What about nth term? That is this one. So a into r raised to n minus 1. The whole raised to n is already there. So this is nothing but a square. So a raised to 2n into r raised to n minus 1 into n. This is 2. And therefore you can see that both are equal from 1 and 2. So from 1 and 2 we have p squared equals to a into b the whole raised to n. Right. Both are equal. LHS equals to RHS. I repeat, see, a1 and an you are given. I wrote the n terms of a geometric progression. Their product equals to p. A how many times? N times a raised to n. Here just adding components. So 1 plus 2 plus 3 up to n minus 1. For that you have used this formula. What we did, we have just added these n powers because bases are same here. Now what is this? That is just this formula, n into n plus 1 by 2. What we did, we have just placed n minus 1 in place of n here. So we have this. I want square, so squaring. So a raised to 2n, this 2 will get cancelled once you square this. So we have this. Now let's start with RHS. And we have started with this. What is A? First term as it is. What is B? Nth term. I've placed the value of nth term here. And then just simplifying, we are getting this. Okay. Question number 24 now. 24th number. Let's see what it says. Show that, in 24th, show that the ratio of sum of the first n terms to the sum of the terms from n plus 1 to 2n is this. Okay. So we want here sum of the first n terms of a GP. So for a geometric progression, you want a1 plus a2 up to an, which is sum of the n terms, that is Sn, which is given by a into r raised to n minus 1 upon r minus 1. Let's call that as 1. Fine. And now next n terms, please read the question. Sum of the terms from n plus 1. So an plus 1 plus an plus 2 and so on up to a to n. Right. These are again how many terms? N terms, remember. Number of terms equals to n. Fine. Here also you can see number of terms equals to n only. Equals to here a. A means the first term, which is an plus 1 into common ratio, so it is same, r. Number of terms is also same, n minus 1 upon r minus 1. I just repeat this, see. Here, actually you should write in the beginning, for a geometric progression, let a1 equals to a and the common ratio equals to small r that you are given. So here first term is a, common ratio is r, so r is to n minus 1 upon r minus 1. For this summation here, number of terms in n, common ratio is r, but first term is not a. What is the first term? That is a n plus 1. Fine. Now you can write also what is a n plus 1? A n plus 1, that is n plus 1 term, a into r raised to n here. That is n plus 1th term, a into r raised to n minus 1. So we have this. Now just from 1 and 2 you take the ratio. That is what you are asked. Taking ratio of 1 and 2. Ratio of 1 and 2. So we have, you can see that once I take the ratio, this will get cancelled with this. We are just left with these upon this, a upon a n plus 1. But what is a n plus 1? That is a into r raised to n. And this will again get cancelled, so you have 1 upon r raised to n. That's what you want, right? You are asked the ratio of sum of the n terms to the sum of the terms from n plus 1 to 2n is 1 upon r raised to n. The only important thing you need to notice, your first term is this. When we write normally first term we put a. Obviously for this a1 is a, but here first term is n plus 1. So a n plus 1. This common ratio is same, number of terms is also same. So if I just put the value of a n plus 1, here it is this. And now taking ratio of 1 and 2. So we'll get the 1 upon r raised to n. Fine. Let's go to next, 25th number. Okay. You are given 4 terms in geometric progression. You are given that a, b, c and d are in geometric progression. So therefore this is the first term a with let's take ratio equals to small r, right? This is our assumption. So therefore b has to be, a as this into this. C has to be third term, that is AR square, and D has to be what? AR cube, right? That's quite obvious. AR square, AR cube. First term A, second term is first term into common ratio, that is AR square and AR cube. Everything you converted into A and R. Now I'll just tell you what you need to do. Start with LHS. A square plus B square plus C square into here b square plus c square plus d square. Now you just put the values of what? This one. A you are going to keep as it is, a square. What is b? That is AR, so a square r square. What is c? That is AR square, so you have a square r raised to 4. Put the value of b here. Then this is c here, c square, and this is d square, right? And then just you simplify, call this as 1. Simplify means take r square common, keep those two brackets as it is, do not open. Same way you go to just RHS. Okay, I'll go to RHS. What is RHS? That is AB plus BC plus CD the whole square. Put the values of A and B. A I'll keep as it is. What is B? That is AR. B is AR. So A square R. What is BC? Just take the product. If I take the product of B and C, it is A square R cube. What is C and D? That is again, you will see A square. We are taking product of C and D here. That is A square R raised to 5. The whole square, sorry. You can find a square common here, but if you take it outside because of the square, it is a raised to 4. r is common. If I take it outside, it is r square. So here you will get the 1, a square already taken outside, r is taken. So this is just r square. A square I have taken r outside. So this is r raised to 4. Call this as 2. You will notice that here the 1 is exactly this. Just simplify. Whole square is there, I'm sorry. This square is there. Here from these and these you will get the square. And from now 1 and 2 you have LHS equals to RHS. Fine.